Okay, so this is your actual course curriculum, right? So today it's a day one of actually it's yesterday we had we had an introduction session. In that we were discuss about the course curriculum only, right? And so from today onwards only officially this course is starting, right? So official content we are going to discuss. So first day one, which is talk about the introduction to the firewall, and day two I'm going to give you the introduction to the Fortinet, and we are going to discuss about the security fabric. Okay, so here we are going to discuss about the firewall. So those who are very new to this firewall technology, if you're not working with any firewall product, so right. So today we are going to start from the scratch. So from what is firewall to the type, mostly we will discuss about the what are the type of firewall we have and what is the difference between the uh, those firewalls, and why we need to learn, why we need to use the next generation firewall, right? So that and all we are going to discuss with the scenarios. Okay, so I think it's that. Okay, guys. So let's go with any idea, guys. What is firewall? Any idea? You can share your thoughts. Okay. Any idea? What is firewalls? Guys, it's a blocker. Okay. Any ideas, guys? Anybody? You can just share. It doesn't mean I need any definition and all. Okay. So may I know who is in the name of user? So please come up your name so that I can able to understand who is attending the session. I can able to call you, right? So yeah. Okay, firewall, it's a wall that filters the traffic, and then it's a device that permits or deny the traffic based on the set of the rule assigned on to it. Okay, fine. Firewall, it's a hardware device. Okay, fine. So others, any ideas? Firewall is a security device which is used to secure our network. Okay, fine. Okay, fine, guys. That's fine. Okay, so it's allowed and deny the traffic based on the uh, policy is configured. Okay, fine. The the network flaws. Okay, fine. Okay, enough, guys. Thank you so much. So, okay, guys. So, if you are collect all your points, right? So, you can give a definition to your firewalling. What is firewalling? That you can give us a definition, all your points. Okay, so I'm going to say, I'm going to give some info about firewall. I'm going to give my thought, what I'm thinking about firewall. Okay, so firewall, maybe it's a device. It can maybe a device hardware, or it can maybe a software. I'm talking about the operating system, VM message. Okay, software. Okay, so which is going to control and monitor. It's a mechanism. It's using a mechanism to, right? So it's which can help us the control the control network traffic, control the traffic, and monitor the traffic. So monitor, or you can say it's a deep inspection. Firewall, it's a device, or it may be, you can say it's a hardware device or software. It's in a VM application. right? So that might be any terminology. It's an application firewall, or it's a hardware firewall, or VM firewall, anything, right? So which can do control the traffic and monitor the traffic. Okay, so all you guys are given a definition only for with the controlling perspective. So most of the commands I get about the controlling perspective only, the fire device which can help us to control allow or deny the set of traffic whatever we need based on the rule, right? So that's what I get a your answer. Most of the answer I got this only, and I'm not getting answer from anybody from this perspective. So I'll tell you what is mean by control and what is mean by deep inspection. So the if it is a firewall, yeah, look, as my question, so firewall, the firewalling will do control the traffic only, but due to nowadays necessity, we need to monitor the traffic, we need to inspect the traffic. So if it is a next generation firewall, right, if it is a next generation firewall, it has to do these activities. So if you want to, I filter the nowadays threats and modern day threats, malware, spyware, virus, all right. If you want to detect the virus and if you want to control that, right? So that, and if you want to detect the attacks, vulnerabilities, and if you want to control it and avoid that attacks, then the device need to have a capability to do control plus monitor, control plus deep inspection. Okay, so if now which means if it is an effective firewall, it's which need to do these two activities, controlling the traffic and monitoring the traffic, or you can say it's a deep inspection instead of say monitoring, a deep inspection. Okay, so sorry guys. Okay, so firewall, it's a device, or maybe it's a it might be a hardware based device, or it might be a software, just an operating system, or it's just an a VM, or it's just an application, okay, which need to do control and monitor the traffic. Okay, so that is called firewall. Okay, so firewall will do control the traffic and monitor the traffic. Why we need to control the traffic is that is very important. Why we need to control and why we need to monitor the traffic. So we are controlling the traffic, then why we need to monitor the traffic? That's we need to know. Okay, so controlling means, as your from my your answer, I'm going to derive controlling means we are going to, let's say this is my network. Okay, I have a simple network. It is connected with a switch, right? And this is my firewall. Let's assume this is my firewall. Okay, or else without having firewall, let's assume I don't have a firewall in my protection network. I have an L3 device, maybe it's a router, and to connect the internet. Okay, so 10.0/24 network I have, or let's say, okay, fine, I have 100.0/24 network I have. Okay, this is my internet. Okay, 10.1. Okay, so this is my internal network, right? So now this is my system A, which is having 10.1 IP, and which system B, which is having 10.2 IP. Okay, /24 network. So these system A and system B, they are going to access the internet, right? So I mean, so they want to communicate with each other, so they already connected with the same LAN, so they can able to easily communicate. But due to my official needs, sorry guys, official needs, I need to communicate with the internet. So it's we are allowing the internet access, so we need a one routing device, right? So we need to communicate, we need a routing device from one network to another network if you want to communicate, right? So we have placed here, we have placed one router, and for our internet purpose we are connected this router with a or IS public network. Okay, so now the user want to the my LAN user want to access the internet. So this device is responsible for that. NAT, I have applied everything. L3 functionality, routing and NAT is done by this device, which is called router. Okay, so now I have allowed the internet access. So my LAN users can able to access the internet, right? So normally all if you placed a router, right, so without having if without implementing any ACLs, right, so normally if you have a connected with the internet, anybody from your LAN subnet can able to communicate with the internet. So if you are allowing everyone to access the internet, what will happen, guys? Okay, this is an office network, right? So everyone can able to access the internet without having any restriction. What will happen? Let's say this user A, he if he knows he can able to access the internet, and during the office hours he will just chit chat with someone else in a social networking, or he will try to download some other files, right? So maybe the audio video files or text, anything whatever it is, right? So he will try to do some activities in the internet. Okay, so that is first part. Okay, so first thing, because of that, what will happen? First thing, so if you are simply allowed everyone to access the internet, first of all, bandwidth wastage. Yeah, just a minute, guys. Type it right. First drawback, bandwidth, right? So bandwidth, and second thing, so in a production network, we use some of the costliest WAN link like MPLS. So if you are allowing like this, what will happen? So everybody will try to download some of the files and video, audio in movies or so whatever it is. So the games, right? So softwares. So because of that, first thing, bandwidth wastage. Second thing, no productivity. They will not going to use. They are going to use the social networking and all, and they are going to misuse the office timing, right? So because of that, your productivity loss will be happen. And apart from that, third, security risk. Okay, security risk. This is the most important thing. What is security risk? So if you are trying to allow your internal users to download, I mean, sorry, your LAN users to access internet, and if you're not having any restriction, the same way from internet anybody try to can, once if you're connected with a public network, if you're not having any restriction points, right? So from internet, let's say not only your internal users, LAN users are trying to access the resources over the internet, the attacker also try to access your internal resources, and they will try to gain unauthorized access. They will try to take at this machine as okay on their control, or this machine on their control, or they will try to take a control of your storage machines, right? So I mean storage servers, or whatever the server you have, they will try to control. Okay, so by controlling that machine, they will injected some malicious things, and that will be the device which communicate with some other device, that will also will be affected. So your network, your entire network resources will be affected, first thing. And second thing, data leakages. So once they have bypassed your network, they will try to steal your personal information, sensitive information. Okay, so because of that, there are two chances. Resource crashed. See, they will try to crash your resources. They will try to shut down your servers, or they will may make some impact in your network, so that so it will make slow down your network, or else your resources will be crashed. They will try to uh, encrypt your data, your entire machine, right? So a machine state, your resources. So you have, and they will to, let's say if it is any ransomware attack is happened, they will encrypt your entire machine. So if you, until unless you're getting a encryption keys from that attacker, so you'll not able to open the machine. and they will steal your personal information as well, your business information as well, right? So because of that, resource crashing will be happen. And then fifth, data leakage. Okay, data leakage is happening, guys. Because of that, there is a lot of security risk. So the you can this is first one. The first two reasons, it's not going to affect your network. I mean, if your resources, it's not going to affect resources more, but it budget wise, it will make a huge impact. But these three last three, right? So up to 3 to 5 points, it's affect your entire network and as well as your reputation as well. Once the lead data leakages happen, the clients will not trust you, right? So there are security risks, so you should not blindly allow everyone. So that is the reason we need to control the traffic. So I don't want, first of all, I'm going to focus these two things. So how to increase my productivity and how to reduce my bandwidth wastage. Okay. So that's for that reason, we should not allow your internal users to access any services over the internet, right? So we should have some control. We know our internal LAN users, what they are going to access, what kind of up for their job process, their business activities, right? So what kind of application they need, what kind of service they need over the internet, and what is the server they are going to access over the internet, right? So that we are clearly know that, so we can avoid unnecessary access given to your internal users, right? So by that we can do it by the help of controlling system. So when you're using a controlling system, we can we what does mean by controlling system? We are going to restrict the access of your internal and external users unnecessarily to access your infrastructure, as well as your internal users unnecessarily access your external network and over the internet. So the unnecessary access we are going to restrict by the help of controlling mechanism. So controlling mechanism means how we can control the traffic by the help of policies. So our access control list, access level, we are going to restrict, we are going to create some rule who are all going to access what kind of application, what kind of services, what kind of files they are going to try to download or upload, right? All the restrictions we are going to set it by the help of policy, security policy. We are call it as a so in Cisco ASA, Cisco ASA and Cisco FTD, we call it as a access control list by, right? So another firewalls, we call it as a security rule or policy. Okay. So all the terminology is same. So by the set of rules we are going to create either to allow or deny, right? So both we are going to control by the help of the by the help of your firewall device, we are going to use one control mechanism, and by the help of security policies. That policy you can create based on the IP address. You can set the access, either allow or deny the action you are going to do it, and that you can set the rule based on the IP address, based on the, I mean, layer 3, which is IP based filters. So source IP and destination IP, right? So source IP and destination IP as a filter, and then source network and destination network as a filter. So which is L3 filter, right? And then L4 filters. Layer 4, you can filter the traffic based on the protocol and port numbers, right? So the protocol either TCP or UDP. Layer 4, protocol wise, and port number or services. Okay, service wise, you can filter the traffic source port number, destination port number, and protocol, right? So based on that, you can filter the traffic. You can use a control mechanism in under transport layer. Okay, and and along with that, you can all next generation firewalls will support layer 7 filter as well. So when you're using a next generation firewall, you can filter the traffic based on the application as well, not only source IP and destination IP, and not only source port number and destination port number and services, not only services and IP addresses. Along with that, the application also, application, what kind of application, and micro application also. It's possible. You either, let's say if you want to allow Facebook, but inside the Facebook I want to deny Facebook chat micro application, right? So in that case, that is also possible by the help of layer 7 filters, that is called application filter. And along with that, so you can filter the traffic based on the application wise as well. Along with that, user ID, user identification rule. So you can set the rule, those who, which user, which employee, you can create a you can create a set of access level for the set of user groups. So let's say you have a two different team in your production network, right? So let's say system A belongs to sales team and system B is belongs to technical team. And the employee who is working as a salesperson, he need to access the social networking application to promote our product. But the employee who working as a technical person, I don't want to allow social networking access for him. I just want to allow the ticketing tool or whatever that things he need for his job perspective. That application only I want to allow it. And so he may sit anywhere else. So he may sit system A or system B, but he is belongs to sales team. And I'm going to allow the set of access for the sales team peoples. And I'm going to allow a deny set of the access for the technical team people. They may sit anywhere else in your office. So based on their login credential, based on their user ID, I just want to control the traffic, right? So that is possible. So by the help of controlling mechanism, so that is possible when you have a next generation firewall, not traditional firewalls. Okay. So that part types of the firewall, I'll come later. Okay. So as of now, we are aware what is control system, right? What is mean by control? Why we need to control the traffic? So, and to avoid the unnecessary access gaining as well as bandwidth wastage, and then productivity wastage, right? Productivity loss. To avoid that, we are restricting the services. We are whatever the we are clean, right? So we clearly know what kind of application, what kind of service, what kind of access we have to provide for the internal users to go for a internet access, as well as from the internet anybody, if you're running some services in your production network, so over the internet some of the user want to access, right? So in that case, that is also we are restricting. So who can access from the internet to your internal networks, that is also we are restricting by the help of control system. So right, so control by creating security rules, guys. Okay, while creating the security rules as a filters, or you can say instead of say control, or you can say it's a filter as well. Okay, so we are filtering based on the L3 datagram to L7 datagram by using the L3 filters such as source IP, destination IP, source network, and destination network as a filters. And in layer 4, source port number, destination port number, and then protocol numbers as a filter, either TCP or UDP, either what kind of service, the web services, mail services, DP services, whatever the services you are accessing, right? So based on that, you can filter the traffic under layer 4 filters and along with layer 7 filters. So what kind of application you are going to allow, right? And what kind of, I mean, those who are going to access that application or services, right? So that you are going to achieve by the help of user identification features. Okay, so that comes under the layer 7 filters. Clear, guys? So by by controlling your traffic, we can avoid, first thing, we can reduce the bandwidth wastage. So only the allowed services and application, and then uh, allowed user only can access so and so services, right? And second, because of the restriction, unnecessary access, to avoid the unnecessary access, so they will not have any options to entertain in a office work, so office timing. So obviously they'll focus on the job right? So your productivity will be increased, so that we have eliminated. And so third and fourth, fifth option, we eliminated only 50% only by using control mechanism. Okay, so whatever the traffics we need over the LAN internal network to access the internet, as well as internet to access your internal network, that we just control by the help of security policies, and we just assign the security filters by from layer 7 layer 3 filters to layer 7 filters. We properly assigned, so everything is fine, but right, everything is fine, but still your network is not 100% secure, right? So what is the importance, then what then what is the importance of just, I mean, as of now, as a firewall, it's just it controlling the traffic. So firewalling, it is doing firewalling, that's it. It just control the traffic. So but still, even though if you have one firewall, right, by you're creating a security rule to allow or deny some access, right? So but still you cannot say your infrastructure is secure. The reason, even though it's allowed traffic, I'll give you an example. So let's say I just allowed system A to access the internet, right? So I have created the rule to all deny unauthorized access gaining. So I just allowed only internal users to only to access the internet. As of now, I don't want to allow internet users to access the internal network. So only my trustable users are trying to access the internet. So that's how I just created the rule, and I allow internal network users only. I just want to allow internet access, and I just want to allow internally they can able to communicate. That's what I did. So now my network is 50% only secure. I can say it's only 50%. Why I'm saying that? Even though the traffic is allowed, let's say I'm giving that, so system A salesperson, so he is allowed to access the social networking application, or he is allowed to access some sales lead applications, right? So that over the internet. So he tried to download some file in the social networking or sales lead applications, whatever the so and so application we are allowed to him, right? So in that case, so that file might be infected. Let's say he's trying to access over the internet. So he's trying to access the Facebook. Let's say this is a Facebook server, and this FB server, while try to access the Facebook, he's try to download some file, some audio, video file, or some text file, anything. Okay, so some of the content he tried to download that file. We are not sure because we are in the internet. So that file, it's already infected with a so and so malware or spyware. Okay, so let's assume this server machine is bypassed by the so and so attacker in anybody. So already it is infected by the malware. Okay, so or spyware, we are not sure, right? So already this machine is infected, the server machine is infected. So the salesperson now he try to download some file, right? So that might be any file, but the traffic is allowed traffic and trustable traffic only. So normally, according to normal firewall, so it just control the traffic and it will check whether the traffic is already authenticated. Yes, it is already authenticated. So the so and so source user is allowed to access so and so Facebook application, right? So the traffic is allowed according to the firewall, and traffic is trustable according to the firewall as of now. Okay, so by based on the security rule only it is authenticated, and now it is allowed. So the user is started to download that file, but unfortunately that file contains some virus or malware or some of the threats. So some of the attack is inside the file. The hacker is injected some malware, right? So in this scenario, what will happen? So as soon as he download that application or file in this machine, right? So the malware will be injected on this file, sorry, in this machine. So hereafter, whatever the any other machine it's try to communicate internally, right? So system B, system C, like that, whatever the machine you have, so they will try to communicate with internally. So that machine also will be infected because this system is already infected by the malware, which is in when they try to communicate with the Facebook app server. So the Facebook server also it's already infected with the malware. So this file, this your internal network system, it's also infected, and whatever the machine it is trying to communicate with system A internally, that machine also will be infected because of they communicated with a infected machine. Okay, so now what happens? Even though you have a firewall, the control system you have, but there is no security. So I just infected that it is infected with the virus or malware. So maybe the virus and virus it will replicate itself, so it will not harmful. Let's say uh, the attacker used that malware to steal. They injected some dangerous spyware or malware which is collect your personal information, and it will hand over the personal information with the attackers, right? So in that case, again there is a chance data leakages will be happen, and resource will be crashed, and security risk. There is, I mean, under security risk means, so your all this comes under the security risk only. So based on the attacker's perspective, either they will collect your personal information, or they will crash your machine, or they will make slow down your network, right? So it's totally depend on the attacker's perspective and what kind of technique they use based on that. So even though you have a firewall, and by using a security rule to control the traffic, that is not necessary. Okay, I mean, I mean that is not uh, if sufficient to control, I mean, to achieve more security in your infrastructure. Okay, so that's the reason it's not enough just having a control system. So we need to, even though the traffic is authenticated and and say by security rule it is allowed, as per the rule it is allowed, even though it's allowed to traffic, we need to monitor. So we need to deep inspect, so whether that allowed traffic is secure traffic or not, whether it is already infected by the virus or malware, or any attacker is use any third party infected virus or applications they use to bypass our network, right? So they are stealing some personal information or not, right? Everything we need to examine. So that examine process is called deep inspection, and that also your next generation, I mean if it is a efficient firewall, the firewall needs to do deep inspection as well. Okay, clear guys? So that's the reason we need to deep inspect your live network, whatever the traffic network flow, right? So the traffic flow that we need to deep inspect, and that we do it by the help of IPS functionality, or IPS. It's a, I mean, it's an internal part of your firewall process. Okay, nowadays next generation firewall internal feature, okay, which can do deep inspect your inspect your live traffic, even though it's an authenticated traffic, authenticated by the firewall rules, and it is allowed, even though it's allowed, and we need to do deep inspection. So if anything is vulnerable, we identify that IPS is identify anything is a vulnerable, right? Anything is the data, the traffic is misbehaving, the data is misbehaving, then it will be either the action you can take, either you can deny that communication, or either you can send an alert to the network and you can allow, or simply if you want you can allow. These actions you can able to take it by the help of this deep inspection process, guys. Okay, so if it is a firewall, next generation firewall, it has to control the traffic and monitor the traffic. Clear guys? Any doubts up to now? So what is firewall? I hope, are you clear in that? Okay, guys. So shall I move on to the next thing? So what are all the type of firewalls we have? Okay, types of firewall. We have a actually firewall types. Any idea guys what are the type of firewalls we have? Guys, Okay, can you tell me some of the firewall products name? Okay, I think okay, Paloalto, stateless, okay, stateless firewall, stateful firewall. Okay, okay, fine. Okay, guys. So according to me, I'm going to classify the uh, firewalls in a different way. Okay, so by the functionality wise, I'm going to define first. I'm functionality wise. Either you can split up the firewall types based on the physical appearance, like hardware based firewall and software firewall, or you can say it's a VM firewall as well. Okay, or application firewall, right? So that also you can say software firewall. Okay, and functionality wise, I'm going to define endpoint protection, or else endpoint firewall. You can say it's an endpoint firewall as well sometimes. Okay, and network firewall. Okay, so apart from the physical appearances, I mean hardware based also, apart from that, you can classify endpoint protection firewall or network firewall as well, and network firewall. Okay, so any idea what is mean by endpoint protection? Okay, yes, so any example for the endpoint protection? Can anyone tell me? Yeah, that is an laptop is an endpoint. So in any features, I mean any application or any software which you used to protect your endpoint. So like antivirus, we have a lot of antivirus, right? So antivirus application, right? The same can so the same application, that applications are called uh, endpoint protection, and endpoint firewall, and all that firewall, all that applications are not working as a just like a firewalls. Okay, but having a features to do deep inspect the traffic to identify the vulnerabilities. Okay, so that's the reason I have mm, classified your firewall type as a endpoint protection and network firewall. Endpoint protection can do deep inspect the vulnerabilities, and once the traffic, or once the virus or malware, that so and so, which is head into your network, and it will do deep scan, it will, and then it will remove it. Okay, the endpoint protection not have a capability to protect your entire infrastructure, and endpoint protection will have a capability to protect only that particular single device. Okay, and so another classification that is called a network firewall, these device example for the one of the best example for the endpoint protection firewall, Windows Defender. In a daily basis we are using a Windows machine, right? So you can see there, you can see one firewall, Windows Defender firewall, or sometimes we call it as a Windows firewall. Okay, it's the best example for the endpoint protection. Okay, so and network firewall, which can secure your entire infrastructure. It's not just like endpoint protection. Endpoint protection can capable to do secure or detect the vulnerabilities, right? Only on that specific device, not for entire network. But if you're using a network firewall, that network firewall, it's It will act like a gateway, and it will entirely protect your entire infrastructure. It will avoid, it will, when the vulnerabilities are tried to enter into your infrastructure, right, in your infrastructure, in your network, in the beginning itself, it will identify it, and it will avoid that, it will take action against that vulnerabilities. Okay, so that is, and it can capable to do secure your entire infrastructure, entire network, but endpoint protection is not capable to do that. Okay, so here whatever the product we are going to learn, like Fortinet, Checkpoint, Palo Alto, Cisco ASA, and Cisco FTD. All these firewall products are network firewalls. Whatever we are going to learn, so that is net comes under the network firewall categories, guys. Okay, so clear. So this network firewall further, I'm going to classify stateless firewall, stateful firewall. Okay, or sim or sorry, you can just simply say that I can further classify traditional traditional firewall and next generation firewall. In between we have a application or UTM firewalls. So that is, along with all, nowadays all these features are, there is no much difference in between the UTM firewall and next generation firewall. UTM fire, I'll let you know the difference between the UTM firewall and then next generation firewall. So I have included that inside the next generation firewall only. Okay, so traditional firewall and next generation firewall. Okay, so this traditional firewall, yeah, from yeah, from where I want to repeat you. Endpoint protection, it's an antivirus. Your antivirus can have a capability to protect your entire network. It's not possible. Endpoint firewall, it's just you can get example for the endpoint protection. So you can say all antivirus applications and your Windows Defender firewall. Okay, that firewall will secure your that particular in one device, which is your laptop or desktop. That device only, or that that operating system only, it will be secure, or it will try to detect the vulnerability, and it will try to take action against that vulnerability, whether the particular service or application you are going to allow access, right? So that you can able to do it little more, only little functionalities only you can able to do that, but still that will protect your individual device, not your entire network resources. Okay, right? So that is possible by the help of network firewalls. Yeah, let me give one by one, Ramesh. Okay, so I'll go one by one. Okay, so the network firewalls I'm going to classify as a traditional firewall and next generation firewall. Okay, so traditional firewalls still further, I'm going to classify as a stateless firewall and stateful firewall. Okay, stateless firewall and stateful firewall. Okay, and next generation firewalls also called stateful firewall. Stateful function only it will do. Okay, so right, so what is mean by stateless or packet filtering firewall? Packet filtering or packet switching firewall, you can say. Okay, so stateless firewall and stateful firewall. So stateless, let me show this. So traditional firewall, and I'm going to classify as a packet filtering and stateful. Sometimes you can packet filtering, you can also call it as a packet, sorry, stateless firewall. Okay, so example for packet filtering is your router. Okay, so I mean your router L3 device router can filter by using routers. We can filter the traffic, right? Clear? Yes, guys. So how we can able to filter the traffic by using router? The same scenario I'll draw here. So this is my router and this is my ISP network and this is my infrastructure and here the same system A and system B. Okay, same 10.10, 10.20 and then 10.1 and this is 100.10 /24 network. Okay, so now I can you I don't have any firewalling device. I have only one router in my scenario. Okay. So before having a firewall, right? Before finding the firewall, we use router to filter the traffic. We just control the traffic by using routers only, right? So by the again in your router, you can create an access control list, right? So by through ACLs, you can able to exactly. Okay. So by using a normal routers by creating ACL, we can filter the traffic based on the L3 filters and L4 filters. Okay, layer 3 and layer 4 filters, which means based on the IP address as a filter source IP and destination IPs or source network and destination network and based on the protocol and port numbers TCP, UDP, either TCP or UDP are what are the port number with services. Okay, HTTP, HTTPS, mail services, I mean, file FTP, file transfer services, right? So based on the protocols, we can able to filter the traffic, right? So if you are using that router as a firewalling system in your production network, so that is packet filtering firewall. Okay, so now you are using that is stateless firewall. Okay, that is also called as a stateless firewall. Why? Okay, so why nowadays we are not using your router as a filter? Okay, and what is the difference? What is the drawback when you're using a router as a filter, and why we need to move on to the instead of stateless firewall, why we need to move on to the stateful firewall? So that's the scenario we are going to discuss now. Let's say I have a router now. I just want to restrict some services. I don't want to allow system A to access the internet. Okay, so system A to access the internet and system B I want to access the internet. System A I don't want to allow access the internet and system B I want to allow access the internet and especially Facebook. I just want to allow Facebook over the internet for system A and system B I don't want to allow. Okay, so by using router you are going to create a rule, right? ACL you're going to create and you're going to say so and so IP address 10.10. I want if it is a 10.10 and protocol protocol is TCP, right? And port number web service. I just want to allow web services. Port number 80 or port number 443. That is web, right? Let's say 443, right? So L3 filter and L4 filter, right? I just action I want to allow simply, right? I want to allow if it is 10.20 and the same TCP protocol and port number 443, which is HTTPS services, I don't want to allow. Okay, so now system we just created a rule as per and we have attach the rule on your incoming interface itself, right? So now what happens, so as per the rule as per the rule it will check the ACL and as per the ACL that it will allow if that filters are matched it will allow, right? And if filters are not matched, if your filters are matched to deny, then it will deny, right? So now what happens, 10.10 is allowed to access the internet. So let's say he is trying to download some file. He is accessing the internet, and now first ASIL is executed, and he tried to reach the Facebook, and he tried to download some 150 MB size of file. Okay, so this file is converted as a 1.5 each IP packet. So almost 100 IP packet will be converted this file. So let's say he's tried to download that file or let's say he's trying to upload the same 150 MB data in the internet. Okay, so like that 150 packets will be converted. Let's assume each are reaching to your interface. Now what will happen when you're using a packet filtering as a firewall, packet filtering as a firewalling mechanism, right? Stateless firewall, what will happen? So each and every packet, it will check what, since it's a L3 device, right? It will understand the packeting IP packets only. So each and every IP packet, it will check based on each and every IP packet based on the rule, right? It will execute the ASL again and again. The same 10.10 is going to access the let's say 200.10, it's a destination, and that is FB server, and each and every IP packet ACL execution will be happen. First thing, first drawback. So even though it's already authenticated traffic and this is it's a same session, same user, he is trying to access some FB server and he to try to upload some data in that FB server, right? So that is the same session, same user only, but still each and every IP packet, it is converted as 100 IP packets, and each and every 100 each and every IP packet will be authenticated again and again, executed by ACL will be executed. So because of that, multiple time ACL execution. So multiple time ACL execution has happened. So this is first drawback why I'm saying that. So even though it's allowed traffic, right? So multiple time ACL execution has happened. So that's fine. Now we have only one individual machine in that standard 10. If we have a thousands of let's say the single user initiated the 100 different session, so the simultaneously he try to access Twitter, simultaneously he try to access some other application over the internet, right? So in that scenario, each and every session it will be authenticate each and every IP packet, whatever the data he is trying to initiate, try to upload or download, right? So all the IP packets, ASIL execution will be happen again and again. And apart from that, for the reply packet, right? Even though, so let's say acknowledgement is getting and reply packet, for the reply packet also, return traffic also need to be authenticated. So if you don't have a rule to accept the return traffic, it will be drop the packet. So first is multiple times ASIL execution. Okay. And second thing, sorry, need to accept return traffic, replay traffic. Okay, return traffic are need to be accepted. So that's the reason. So that these two reasons are more very difficult. Okay, so to manage your end, to block or allow any specific traffic, so we need a return traffic as well. With return rule, we need to accept the return traffic rule as well, we need to create separately. So that is very difficult to manage. And then due to multiple ASL execution, it's utilizing the it's over consuming the hardware resources, bandwidth wastage, that and all it's happened. Okay, so the reason why we need to accept the we need to create a to accept the return traffic, we need to create the rule, because they are using a packet filtering. Packet wise, they will try to uh, they will try to control the traffic, and it's just identifying the traffic based on the traffic only, right? So based on the packet only, and they are not having any record. So after even though it's a packet filtering, packet based switching, right? So they are not having a record, they are a stateless firewalls, stateless method. They don't have any record for the previous authenticated traffic. Okay, so even though it's a live session, right? So they don't have a record, any record, because they are not maintaining any state information. So and so the user is initiated the traffic to access the so and so destination and with the so and so application. So that record is not maintained when you're using a stateless firewall. The packet filtering firewall doesn't have no record, no record to the existing session. Okay, no record. It's not maintaining any record for the existing session, guys. Okay, so these are all the major drawback when you're using a stateless firewall or packet filtering as a firewall. Okay, so what they have think, so how to avoid this drawback? I mean, the major drawback, it's it's executing the ACL multiple time because of that bandwidth wastage, and then hardware unnecessary latency it might create, unnecessary hardware utilization is happen. Okay, and along with that, your router, it's responsible for it's a routing device, right? So it's responsible for the L3 routing update, NAT, VPN, all it's have huge responsibility. So because of that, it is creating a latency in your production network. Okay, so to avoid that, they have later on they have implemented the functionality of working functionality, right? So from the stateless to they make it as a stateful firewall. They have created a stateful firewall, and in a next generation, I mean, in a traditional firewall itself, we have a stateful firewall. Okay, so that they have replaced another device called ASA instead of router. For this position, they have replaced one more device, right? So along with a L3 functionality and with a stateful inspection. Okay, so they have replaced. Okay, this is your ASA firewall, let's assume. Okay, so they have replaced one more device which can control the traffic in a efficient way, and it is maintaining the information, right? So state information for the live existing session and existing session. Okay, so because of that, what happens, previously each and every the same scenario, right? So the user, again, he tried to upload some 150 MB data IP packet, and now what happens, first, okay, so very first time, the same rule I have. So let's say as per the rule, system A can access the internet, right, for the web services. So as the same rule, let's assume we have a same rule. Now what happens? So when system A initiated the traffic to access the internet, first it will check the ACL. As per the ACL, that is the traffic is allowed. So while allowing the traffic, what will happen? It will it will maintain a record. Okay, that record is called connection table or session table or state table. All are same. State information, connection state information, or session existing session information, right? So that record is maintained. So now what happens, whenever system may initiate the traffic and your firewall will execute the ACL, while executing the ACL, it will check what is the source IP, what is the destination IP, right? And sorry guys, and for this source and destination, I'm talking about the traditional firewall only, it will maintain the source IP and destination IP, and source port number, destination port number. Okay, so let's say that is 10.10 and destination IP is, let's say, 200.10. Okay, and source port number, that is randomly generated by your source machine, let's say that is 4450. Okay, and the destination port number, they are using a Facebook is the it's in a web services, right? So HTTP service, they are using a HTTPS. So what is the port number for HTTPS service, guys? Port number 443. So this record it will maintain. Along with that, it will for this record it will give the identity. Okay, for this record, and when along with that, when session is started, okay, so that information, and then session state. Okay, so this information it will maintain one record. For this record, it will give the one identity. So that ID along with the identity, so ID number, so that is called a session ID. So unique number it will give for the session ID. Okay, so along with the session ID, it will maintain all this record. So now what happens, once it is authenticated, it will collect all the information from the source in request packet, and it will maintain all the record. So now what happens, the session will be established and the time will be right. So a session timing established, starting time, everything will be added. So now after that, he tried to upload or download any file during that session. It will not execute ACL, because whenever it is receiving any IP packet, first it will check what is the source. And for that source, do we have any existing session? If it is there, it will look at the session table. Yes, this IP packet is belongs to so and so session. So it will not execute the ACL. So it will, since it's maintaining the session table, session information, existing live session information. So all other packet, instead of executing the ACL 100 times, so now for this 100 IP packet, now it is reducing the ACL execution by the help of state information or state table or connection table, you can say, guys. Okay, clear? So because of that, they have reduced unnecessary ACL execution. So they are maintaining the record. So it is having some existing session information. So it is it's avoid the unnecessary ACL execution. And along with that, since it's maintaining the record, okay, whenever you are getting a reply, if it is a reply traffic, again it will check out the your session table. So we have a record. So for reply is coming to the destination, if the destination your requested source IP previous in a request, obviously it will be a source IP, right? So when you're getting a reply, so reply, the source IP will become a destination IP while getting a reply, right? So that time, if destination is your in your if it is there in your connection table, it will know, it will I mean, you no need any written accept, I mean, you no need to create any rule to accept the traffic, which means no need of written traffic, accepting the written traffic rule. Okay, so that is the major thing. So we can avoid to create the rule to accept the written traffic because of the existing session record, I mean your connection table. Okay, so that's the reason they have, because of that they have eliminated the unnecessary ACL execution, and then they have eliminated the unnecessarily creating the return traffic, for creating a rule to accept the return traffic. So because of that, it can able to handle more traffic, and it is reduce the bandwidth utilization as well. Okay, and it is reduce the workload to your firewall, right? So that's the reason we have to move on, previously from this packet filtering firewall to stateful firewall, guys. Okay, clear? So now this stateful firewall and all next generation firewall nowadays, whatever the firewall we are using, it that is stateful firewall only. This feature is maintained by all your next generation firewall as well. They are maintaining the existing session information by the help of state connection table, creating a connection table. Okay, so now, so again, that feature is there in my traditional firewall, then why I need to move on to the next generation firewall? Okay, so when you're using a traditional firewall, it's ASA, it's an example for one of the traditional firewall example, Cisco ASA. So your ASA can filter the traffic. Your traditional firewalls, even though it's a stateful firewalls, it can filter, it can control the traffic, it can control the traffic, which means again you can use your the advantage of having a stateful firewall that's maintaining the connection table. And what is the pros? Layer 3 filters, you can use layer 3 filter and layer 4 filter as a control purpose. Okay, I mean to filter the traffic. So IP and protocols and port numbers, you can use it. Again, it's maintaining the connection table. And then cons, what is the drawback by using your stateful firewall? Even though it's a stateful firewall, the drawback of using a traditional firewall is there is no application layer visibility. If you want to block any specific application, or if you want to allow or deny some of the traffic for the based on the source, I mean based on the user ID or user group, right? So user identification and then application awareness is not there in your ASA firewall. If you want to block some specific application, or if you want to if you want to uh, allows deny some specific users, that is not possible in your traditional stateful firewalls. Along with that, there is no inspection there is no monitoring feature. Your traditional firewall doesn't have a monitoring features, so it will not it you can able to control the traffic based on L3 and L4 filters, and you after control the traffic, you are after authenticated, you cannot monitor the traffic, you cannot deep inspect, so you will not able to identify the vulnerabilities, virus, malware, spyware, anything, right? Any type of attack is I mean injected in your IP packet, that is not possible to identify it in your data, it is infected, right? So that is not possible to identify it. So that's the reason we have to move on. Even though your ASA firewall is a stateful firewall, we have to move on to the next generation firewall. Okay, so next generation firewalls, example for the next generation firewalls, whatever the product except Cisco ASA, we are going to learn, right? Whatever the product, so all that product, next generation firewall, next generation firewall only. So when you're using a next generation firewall, they're using a stateful information. Again, that is a stateful firewalls, and we can filter the traffic based on the layer 3 filters by IP address and then network addresses, right? So subnet we can able to filter, and then we can also filter the traffic based on the protocol and port number wise, and we can also filter the traffic application. Let's say if you want to allow the same users to access the Facebook, and the same user I don't want to allow Twitter, right? The Facebook and Twitter both are using a same services, right? Web services only, same protocol only, they are using same port number only, they are using it, HTTP S services they are using it, right? So both are using port number 443, and both are using a TCP protocol, right? But the application is different. Facebook is a different application, Twitter is a different application. So if you want to block based on, I mean, if you want to control the traffic based on the application wise, so that is also possible when you're using a next generation firewall. Okay, and then you can do deep inspect monitoring. Monitoring is very much possible and very much effective when you're using a next generation firewall. You can, so you can filter the traffic based on, if you want to block some specific URLs websites, right? So or yeah, let's say I want to block entire show sports related websites, entire finance related websites, so category based filters, that is possible. So URL filter is possible, and then a deep inspection against the vulnerabilities, virus, malware, spyware, right? Any type of attack, network type of attack, DDoS attacks, right? And so that is that and all we can able to detect when you're using a next generation firewall, and we can able to prevent that as well. And data leakage protection, file blocking, that is also possible. So by doing deep inspection by the help of these UTM features, all these features are called UTM, Unified Threat Management, UTM features. Okay, so so these features are not applicable in your traditional firewall. So nowadays we to identify, to protect your network from the modern world threats, we need this next generation firewall, because they only have a capability to identify all the these type of vulnerabilities, spyware, malware, and they can able to do deep inspect against the vulnerability. And as well as you can able to achieve the data leakage protection and file blocking, that option or that features also you can able to achieve when you're using a next generation firewalls. Clear, guys? These are all the difference between the traditional firewall and next generation firewall. Okay, and next generation firewall also, it's a stateful firewall only. Okay, clear, guys? And in between, I told you, right? So we have application firewall and we have UTM firewall, right? So so UTM firewalls are small scale industry firewalls. I mean, these UTM features separately, they have a separate devices, dedicated IPS, dedicated URL filtering devices, dedicated application, I mean the web-based application filters, right? So that and all, we have a previously we have a separate products, okay, which can familiar which can filter the traffic and which can inspect the traffic. That features are called UTM features. All these features are UTM features. For this, we have a dedicated separate devices we have previously, and along with that, these devices, UTM devices are not capable to do protect your big environment. So big enterprise network or mid enterprise network n- not able to use this UTM firewalls because their output is very less, since they have a multiple products inside multiple products. So they use the separate products, okay, individually for the separate functionalities, okay. So that is making a latency in your production network, and that is not capable to do provide all the functional they are not capable to do handle huge data flow in your production network. So that's the reason later on all these feature they have implemented in a single box, and additionally they have given a more hardware resources and more capability to handle your enterprise networks, okay. So that's the reason I am not mentioning your ETM features separately, okay. Clear, guys? Any doubts? Intrusion prevention system. IPS full form is intrusion prevention. So anything is a intrusion, right? So anything is harmful to your network, right? Virus, malware, spyware, right? So that can be detected by this machine, this engine. Okay. So ASA, it's a traditional ASA firewall. Okay, ASA, it's just you if you're using, if your ASA doesn't have any NGFW firewall, NGFW features, that is traditional firewall. In ASA also now we have a next generation operating system, that is firepower, that is called FTD. We are going to learn here. Okay. So in Cisco also we have a next generation firewall. Any doubts, any queries, guys, apart from that? And sorry for the long session. Okay. From tomorrow onwards, I'll try to conclude within our duration. FTD is a Cisco firewall only. Yes, Cisco Firepower Threat Defense. FTD means Firepower Threat Defense. That is a Cisco product only. Okay, guys. So if anybody is not there in that WhatsApp group, just ping me in my WhatsApp. I'll add you, and the videos to videos for the today session. I'll share with you the links to access our today's recorded video and in our WhatsApp group. Okay. So tomorrow we are going to head into the Fortinet content. Okay, so I just given an introduction. Yes, Ramesh will be provided. Okay, guys. In case if you have any queries regarding your today's session, or if you want to anybody, if you're new and if you want to join this batch, we have only two seats only left in this batch. Okay, so if you are interested, I request you to complete your admission process. So tomorrow onwards, we'll allow only the paid students only, guys. Okay. Okay, that's it today. We'll meet tomorrow. Yeah, Vakas, I'll share the link. You will get the link in our paid student WhatsApp group. Okay. So I'm creating the separate drive for you. So I'll I'll share end of the day or early morning of the day. Okay. Tomorrow you will get the drive access. Max to max today I'll complete. If not, you will get it tomorrow. Okay, guys, that's it today. We'll meet tomorrow. Bye bye. Take care.